Today's topic is about standing wave, polarization, and the Doppler effect. First, what is a standing wave? How we define a standing wave? Example, two progressive waves, two waves which can change their position, are traveling in opposite direction. So when two waves traveling in opposite direction, when they combine with each other, they give rise to a standing wave. They will give rise to a wave or the resultant of the two waves, which are the two progressive waves which are traveling in opposite direction. As a result, when they combine with each other, some points they will increase the effect of each other, and there are some points where they decrease the effect of each other. So the region, the place where they increase the effect of each other, we call that as node, antinode, and the region where they cancel out the effect of each other, we call that as node. So node means that this is actually a standing wave, a wave which is produced by the combination of two progressive waves traveling in opposite direction. So it is actually a special type of interference, a combination of two waves when they are traveling in opposite direction. So region where the amplitude is maximum, that is called antinode, and the region where they completely cancel out each other, we call that as node. So at antinode, there is a constructive interference, and as they have a constructive interference, they increase the effect of each other. So what is the condition for constructive interference? The phase difference should be either 0 or 360, where the part difference should be lambda, 2 lambda, 3 lambda, and so on. So part difference is equals to n lambda when antinode is formed. And node is formed. Node means the formation of a node means they cancel out the effect of each other, the point where these two waves will join. So at node, or the place where the node is formed, there is a destructive interference. As you can see, the amplitude is 0. So condition for the destructive interference, the phase difference at this point should be 180, and the part difference should be n plus half lambda. And the value of the n can be, if it is 0 then it will become half, it is 1 then it will become 3 by 2, if it is 2 then it will become 5 by 2, so on. So phase difference, the angle difference should be 180 degrees for formation of the node, or the part difference between the two waves should be n plus half lambda. So the simple definition of the standing wave, the wave which is formed by combination of two progressive waves traveling in opposite direction. So when these progressive waves, the wave which can change their position, they're traveling in opposite direction, we call that resultant wave as a standing wave. Is it clear, the concept of standing wave? or interference of the two waves result in standing wave. Now what happened? You can observe the standing wave in a string or a wire. What happened, like example, if the wire is fixed from both ends and I disturb this wire either from the center or any like from one end. So when I disturb one end of the wire, so what it will produce? It will produce a wave. So that wave will travel and this wave will reflect back or bounce back. So actually there are two ways. One which is traveling towards right, another one after reflection is traveling towards left. So as a result, I will not see two waves. I will see the combination of the two waves. So what I will see, I might see that these strings are vibrating in one loop, or they may vibrate in two loops or three loops. So what happened? Like it can vibrate in this manner. This is very common string vibration. Maybe you have seen if you take a rubber band fixed from both ends and disturb from the center, you plug the rubber band from the center. So what you'll observe this type of pattern, which is also called a fundamental frequency or first harmonic. Or you may have a pattern like this. This is one possibility, or more than that. So why there is a standing wave? Again, because to produce a standing wave, what is the concept? There should be two waves which are traveling in opposite direction. They will result to a standing wave. And the region where the particles cancel out each other, will have a node, and where they increase the effect of each other, we call that as antinode. Same thing, this will be node, 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 and antinode. And in terms of wavelength, what is the difference between node and antinode? How we can work out that? As you can see, like example, this is one complete wave. So if I complete and make a standing wave, so this is a standing wave. Now what happened? As you can see, this region where they cancel out the effect of each other, that will be a node. This will be a node, and the third point is also a node. And where they increase the effect of each other, that is antinode, and we have antinode. So distance between the three consecutive nodes, that is equals to one wavelength, because that's the length of one wave. Then distance between successive nodes, that is called lambda by 2, half wavelength. And distance between node and antinode, then what it will become? It will become lambda by 4. So if you have three successive nodes, the distance will be equal to wavelength. If you have two successive nodes, the distance will be half of the wavelength. And you have node and antinode, or antinode and node, the distance will be quarter of the wavelength. Because sometime in the question, they provide you the length of a string and they ask calculate the frequency or the wavelength when speed of the wave is given. So using this formula, using this idea, you can work out the wavelength of a standing wave. We'll drive an expression as well to find the wavelength, the relation between frequency and wavelength for a standing wave. Then you can have a standing wave in the pipe. And the pipes can be divided into two categories. You may have a open pipe, or you may have a closed pipe. What is the meaning of pipe? meaning of open pipe. Open pipe means the pipe which is open from both ends. And the meaning of a closed pipe means the pipe which is closed from one end. That's called a closed pipe. Basically, what happened, like these pipe instrument, these all pipe instrument, they produce, they enhance, they increase the sound as they give rise to a standing wave. So basically, what happened, like example, if you have a closed pipe and you have open pipe, so always at a close end, when the end is closed, at this point it will always form a note, and always at the end, always at the open end, it will form antinode. So here it will form antinode, antinode. So there should be a node between. Now there are many possibilities to have a pattern. The minimum one, like when it produces standing wave. So to represent that but how this standing wave is produced? Like example, you produce a sound, you blow the air. So when you blow the air, the sound energy, basically the energy due to the vibration or motion of the particle travel. So it strike the surface, and as it strike the surface, it bounce back. So the two waves are there, one which is traveling towards the close end and the one which bounce back from the close end. So these are two waves, two sound waves. When these two sound waves combine with each other, interfere with each other, they give rise to a standing wave. And if when they produce an antinode, that is why, like example, if you have a vessel, a container which is closed from one end, and you try to blow the air or you try to speak through this, what you will find your sound will become a bit louder, or you might not observe a sound, or it might be a louder. What could be the reason for that? The reason is that because the two waves which are traveling in opposite direction, they give rise to a standing wave. So standing a wave enhance the, like if antinode is formed, so it enhances the sound. That's why you will observe or you will hear a louder sound. So when we draw the pattern, when we draw the pattern for this standing wave, so because at always at the open end it is antinode and the closed end it is node. So when we draw this pattern, it can be like this. If only antinode and nodes are there, one node and one antinode, it can be like this, or it can be in this manner. Like you may have antinode, always node and node will be there at the closed end and antinode at the open, but in between you may have more, like you may have antinode and then you may have node again. So antinode and node, node means zero amplitude, then again antinode, so means maximum amplitude, and then again node, so minimum. This is how we represent the standing wave. So it can be like this. Same thing for open pipe. The term open pipe means the pipe which is open from both ends. That's called an open pipe. So you may have antinode both ends. So if you have antinode for both ends, so antinode means maximum amplitude and node means minimum amplitude. So you can have a pattern like this. This is one possibility. Then what is the other possibility? That if you have an open pipe means the pipe which is open from both ends. So always at the open end you will have antinode, antinode, antinode. So in between them maybe you have node, then antinode, and then node again. So antinode maximum amplitude, node means zero amplitude. Then antinode maximum amplitude, then node means zero amplitude. Then antinode maximum. And when I just make a show a representation of a standing wave, so it will be like this. But always at the open end you will have antinodes, and the close end you will have nodes. Why at the close end you always have a node? Because when the wave reflect from the surface, it undergo a phase change of 180. So when it undergo a phase change of 180, like example, if crest is striking the surface, the trough will bounce back, and when crest join with the trough, they completely cancel out each other. That is why always at the close end you will have a node. Is it clear, the concept of standing wave in the pipes? So basically, what is a standing wave? The wave which is produced by combination of two progressive wave, that wave is called standing wave. So driving expression, equation and expression for standing wave in a string. Example, you have a string which is fixed from both ends, and you disturb from the center. So when you disturb from the center, what are the possibilities? Because when you disturb, it will produce two waves which will travel in opposite direction. That will give rise to a standing wave. So one possibility is there, it might vibrate in one loop. That is called fundamental frequency or first harmonic. It might vibrate in two loops, and it might vibrate in three loops. And you can clearly see as the number of the loops are increasing, the amplitude is decreasing. So if we say here we have a node and antinode, then here we have a node and node is there, then node and node. The length of this is the same string which is vibrating in different patterns. It might vibrate in one loop, it might vibrate in two loops, it might vibrate in three loops. So length is L. This length is also L, this one is also L. Now, this length, if I want to represent this length in terms of wavelength, because I have two successive nodes, so when two successive nodes are there, that is called half of the wavelength. So I can say the length of this string is equals to half of the wavelength. Why lambda 1? Because these wavelengths are not same. That's why if it is one loop, where 1 is representing the number of the loop, n is equals to 1 means the loop is 1. Here it is two loops. So when it is vibrating in two loops, distance between n and, because three successive, so what I can say it is equals to lambda 2. The length is equals to the wavelength, and if it is vibrating in three loops, this is lambda by 2, lambda by 2, and lambda by 2. So actually it's 3 lambda by, because lambda by 2 plus lambda by 2 plus lambda by 2. So it is 3 lambda by 2. So here the length is equals to 3 lambda by 2. Now we have the formula, or I can also say that 2L is equals to lambda 1. Here I can say lambda 2 is equals to L, and here I can say lambda 3 is equals to 2L by 3. Now we have the formula V is equals to F lambda. So if V is equals to F lambda is there, speed is equals to frequency multiplied by wavelength, and wavelength is equals to, because for here speed will be same because this is a string, same type of wave is produced, speed will be same, but the frequency for first loop is F1 and the wavelength is lambda 1. So V is equals to F1 lambda 1, and we have V is equals to F1. And what is lambda 1? Lambda 1 is 2L, so I can write 2L. This 2L is multiplied, other side it will divide. So I can say if I need the frequency of the first loop, the formula will be speed of the wave divided by 2L. And the second one, as we know, lambda 3 is L. So we have the formula V is equals to F lambda. So V is equals to F2 and lambda 2. F2 is the frequency and lambda 2 is the wavelength. So lambda 2 is equals to L. So in place of lambda 2 I can write L, or I can say V is equals to F2 into L, or I can say V divided by L is equals to F2. If it is vibrating in two loops, then if I know the speed, I know the length, I can find the frequency for the second loop. Then if I need for the third one, as we know lambda 3 is equals to 2L by 3. So if I substitute in the formula, V is equals to F3 and lambda 3. And what is lambda 3? Lambda 3 is 12 by 3. If I solve this, so it will be 3, like F3 will be, I'll write it here because of space, F3 is equals to 3V divided by 2L. So if we generalize the formula for the frequency, if we write a general formula for frequency, we can say Fn, the frequency for n loop is equals to nv divided by 2L. This is a general formula which relate the frequency with the speed and the length. And this formula shows that the length of a string is inversely proportional to the frequency. If you use a shorter wire, it will have a greater, if speed is kept constant, the shorter wire will have a higher frequency or produce more vibration per second when disturbed as compared to a longer wire. This same principle is used in the guitars, the string instruments, that for a guitarist, they have different strings of different thickness, as well as they use their fingers to change the length of the wire which they are disturbing. So using their finger, they change the length of a wire which they use. So from the same string, they can produce a different frequencies or different sound. So if they want to produce a higher frequency, so they tap the wire from the lower side so that a shorter length is used, and that result in a higher frequency or more vibration or a high pitch. Where if they want to reduce the pitch, reduce the frequency, so they use a longer wire, they tap the wire from greater distance from the fixed end so that it will have a greater length and a shorter frequency. Is it clear the concept of this equation in a standing wave? How the standing wave is produced and the relation of the standing wave frequency with the length? So we have this formula Fn is equals to nv over 2l for a wave in a string, or we can say v, the speed, is equals to 2l Fn divided by n. So speed of a wave in a string is given by two formulas. The first formula, which we just derived, that speed of the wave is equals to 2l Fn, and n means the number of loop divided by n. And there is also another formula to find the speed of the wave in a string. V is equals to under root t divided by mu. What is t and what is mu? T is the tension, the force on the wire. And what is mu? Mu is the mass per unit length, or you can just understand in terms of thickness. So mass per unit length, or how much mass is there in a unit length, that is denoted by mu. So when we combine these two equations, what we can say? We can say 2l Fn divided by n is equals to under root t divided by mu. N is divided, other side multiply, so I can say Fn is equals to n over 2l under root t divided by mu. So this is a formula which we will use to find the frequency of any loop. Like example, if we know the length of the string, they mention a string is there which is 3 meter long, and there is a weight attached to one end is fixed, and the other end we attach a load. Example, a 2 Newton load is attached, so tension is there 2 Newton. Mass per unit length, like if they mention the mass of the spring is mass of this string example is 0.2 kilogram, and we know the length is 3 meter, so mass divided by length, what we'll get the mass per unit length, which is the mu. So we will have t, we have mu, we have length. And if we say it is vibrating in one loop, like the pattern was like this vibration pattern. So if you know its vibration pattern, like it's one loop or two loops or three loops, according to the question, we'll substitute n, and what we'll get the frequency of its vibration. And from this formula you can see clearly the relation between frequency and other parameters. The frequency of a wave, standing wave produced in a string, is directly proportional to number of the loops. If I produce more loops, the frequency will increase. It is inversely proportional to length of a wire. If I use a shorter wire, it will produce a high frequency as compared to longer wire. And it is directly proportional to the tension. If I stretch or if I apply more force on the string, it will produce high frequency. That is why even for a guitar, you will find that there are knobs which can be used to change the force on each wire. What is the purpose of these knobs? Actually, these knobs are changing the tension in the string, the force on the string. So by adjusting these knobs, like force on the string, we can produce, if it is stretched, then or a greater force is applied on the string, then it will produce a higher frequency. And it is inversely proportional to mass per unit length. If we use a thinner wire, it will produce a higher frequency as compared to thicker wire, because thicker wire means more mass per unit length as compared to thinner wires. So this is a formula which relate the frequency of a string or vibration of a string with the tension, the mass per unit length, which is denoted by mu, and the length of the wire and the number of the loops. And why you will find for a guitar, they have this inlet for the air. What is the purpose of the guitar? Inside it is hollow and there's an opening. So basically inside the it will act like a pipe. How it act like a pipe? Like if you look from the sideways, like if you look this from a sideways, so air can enter, like as a string vibrate, they vibrate the air, so air column vibrate, transfer energy, bounce back, so air can vibrate, collide, and that also give rise to a standing wave of the air, and that will enhance or increase the amplitude of the sound produced by this guitar. Is it clear, this topic about the standing wave in a string, the pipes, and the derivation which relate the frequency, tension, the mass per unit length? Any doubt in this? Then another topic which is about the Doppler effect. What is a Doppler effect? The term Doppler effect means it is a relative change in frequency due to motion of source or observer. So when the source and observer are moving either towards each other or away from each other, what is actually produced by the source and what is detected by the observer, that will be different, and this effect is simply called a Doppler effect. Example, you have a source of any wave, like example it can be a sound wave, it can be a light wave, any kind of wave, because Doppler effect is an effect in the wave, and you have observer 1 and you have observer 2. Now what happened? First, the source emit out wave. When the source emit out wave, so this wave from position 1, it will be concentric to point where it is released, so it will be at position 1. Now what happened? The source start to move towards observer 1 and away from observer 2. So when the source start to move towards observer 1, and at second position it will produce another wave. So when it will produce another wave, the second wave will be concentric to point 2, means the center of the second wave will be point 2. Then it produce another wave at point 3 as it is moving towards the observer 1. So the third wave again, it will be concentric to point 3. So what you will observe, that these are the wave fronts which I drew. So what you will observe, the position, the point where the source is moving towards the observer. So what he will observe, that he will see or he will observe that the wavelength which he is receiving is decreased, and he is receiving more vibration per second, so frequency will increase. So this relative change actually is not change, but because of relative motion or of a source, or it can be observer, or even both are moving towards each other, or both can move away from each other, but the relative change in frequency due to the motion of source and observer, this effect is simply known as Doppler effect. So here this is moving away. When it is moving away, what we'll observe, that the wavelength appear to increase and the frequency decreases, and this relative change in frequency and the wavelength due to motion of source and observer is called a Doppler effect. this is how the speed cameras are working. Their working principle is simple, based on the Doppler effect or even the radars. So how our radars are able to identify that the airplane is moving towards them or away from, or what it will, using this we can also find the speed. So example, if this is an aircraft, so radar, what it will do, it will send the wave. So it will send the frequency. But when this wave strike the airplane or detected, or a detector is there which is retransmit this wave, so what is received by the radar after the reflection, that the wavelength is decreased. So if the wavelength decreased as compared to what is sent, so example, here the wavelength sent was 2 meter, but what we are receiving is 1.5 meter. So what we can conclude, that if the wavelength decrease, that this object is moving towards. So whenever there's a decrease in the wavelength or the frequency increase, we can say that the object is moving towards each other, or object is moving towards the source, or source is moving towards the object, or both are moving towards each other. An opposite can be done. Like example, if there is another aircraft which is moving away, so when this aircraft send the signal back, as a result it will be a longer, what is sent and what is received will be longer. So what we can conclude from this idea, we can say that basically what happened, that this object is moving away because the wavelength increase, here the wavelength decrease. So the change in the frequency and the wavelength due to relative motion of source and observer, we call that as Doppler effect. This Doppler effect can also be used to identify that, or conclude that, we say universe is expanding. So how we are able to say that universe is expanding? Like this is our earth, and in the lab example we have hydrogen. Every element is having its own spectrum, its own way to emit out energy. So example, we are receiving the radiation from hydrogen, the spectrum of hydrogen on earth in the lab. Now if we focus on any galaxy nearby, example this galaxy is nearby, so when we are examining this galaxy, because it is having different elements, example this also having hydrogen. So what we will do, we are focusing the radiation which we receive from hydrogen present in the galaxy or on that galaxy, and what we observe that on the earth it was say giving say 400 nanometer, but when the same hydrogen which we detect on the galaxy and receiving the spectrum from that, that is approximately like 430 nanometer. So what we can say, what we can conclude about this galaxy, is it moving towards or away? The wavelength which we receive from the galaxy is longer as compared to wavelength of the hydrogen in the lab. So it is giving a longer wavelength. So as it is providing a longer wavelength, so what we can say or conclude, we can say that this galaxy is moving away from us. And this is our conclusion, that why we say universe is expanding, because most of the galaxies are giving this increase in wavelength. And we have the spectrum: violet, indigo, blue, green, yellow, orange and red. So red is having the longer wavelength. In this order the wavelength increase, in the other order the wavelength decreases. So as you can see, if the wavelength increase, what we call that as redshift. Why we call redshift? Because red is having a long. It's not does not means that it is giving out red light. It means the wavelength is getting longer because red is having a longer wavelength. So most of the galaxies are in the universe are giving us redshift. So we conclude that the universe is expanding. But there are galaxies which are giving blue shift as well. So if they are giving a blue shift, it means they are moving towards us or towards our galaxy or towards the Earth. So using this idea, we can conclude or we can identify the motion of the object, whether it is moving towards or away. Is it clear? The Doppler's effect. So we started with a standing wave, this part, and concluded at a Doppler effect. I'll share another link to discuss polarization and pulse echo technique. Is it clear?